This is a brief introduction to the agda-vim vim mode that provides functionality comparable to the Emacs mode distributed with Agda. It utilizes the same interface that the Emacs mode uses, so it has access to the same information. This demo will roughly follow the simple introduction to Agda, but is only an introduction to the vim mode and not to Agda itself. So let's begin. As you can see, and as you would expect, we have syntax coloring, including coloring of user-defined constructors, and we'll see more of that as we go along. You also see that we have support for Unicode characters, and I'll talk about how to input them a bit later. So let's look at the commands that we have available. So all the commands preceded with comma are the agda-vim vim mode commands. They are actually defined to use your local leader, which I've configured to be comma, but by default is usually backslash. So when I say comma L to reload, you may need to do \L or reconfigure the local leader to be whatever is convenient for you. At the top you also see a few other control commands. In particular, Control G jumps to the next hole. So in this case we will want to do a case analysis, so that will be comma C. So there are two ways to provide additional information to the vim mode. The first way I'll demonstrate now, we want to do the case analysis with comma C, and it doesn't know what to do the case analysis on, so it asks us with the expression prompt at the bottom. In this case we specify B, and Agda rewrites the code and creates two new goals for us to solve. And then you also notice that there's a new window that lists the types of the two new goals. If you don't use windows in Vim all that often, which I do not, two useful commands are Control W will cycle through the windows, Control WO will close all other windows. To demonstrate the other way of giving input to the Vim mode, you can provide that input in the hole ahead of time. So in this case, we want this expression to be T, and we'll use the command give to give this expression to Agda and have it type check and include it if it type checks automatically. So comma G does that, and we can see it's rewritten our code and told us now that we only have one goal remaining. If we had put in something incorrect, and I'll use the first style again, so comma G, and I get prompted to enter an expression, and if I use B, I get an error and the code gets left the same. The other common feature that we'd like to use is the auto feature, which will search for an answer. So to use that, you just simply use comma A, and it will guess at an answer, and in this case it guesses correctly. So let's go on to a slightly more involved example. So I'll define the naturals, and to specify the type, I'll use the blackboard in. So to access this, this is using the agda utf8.vim file. So you say \, and then capital N to get blackboard in. And you can look at the agda utf8 vim file that's included to see what other things you can type and what they expand to. And you can add new ones or change them as you'd like. So let's finish this definition. To add the right arrow, besides typing it out like that, you can also use the same kind of Unicode insertion, so \2 will give you a right arrow, or there's a shortcut, Control _ will immediately insert a right arrow. So once we finish our definition, we can use comma L to reload, and we see that it loaded successfully because no error messages were displayed, and it colored the syntax correctly. Let's define addition. As you can see, typically we'll define new functions by specifying their parameters and the body, and leaving the body as just a goal, so that we can then use case analysis or auto to solve for this. So in this case we'll want to do a case analysis on X, so comma C, say we want X, we'll have auto solve the first one, and then we'll try to have auto solve the second one, but it doesn't give us the answer we'd like. So we hit undo to go back. And now the agda-vim mode doesn't know that we've undid that change, so it thinks there's still a y here. So if we try to do something like do a give, we get a goal not loaded, because at this point it thinks all the goals have been solved. So again, anytime this happens, or similar sort of errors like this seem to happen, usually reloading with "L" will resolve them. So we just reloaded, and now we'll actually use the refine command, which takes an expression and then just makes sure it types checks and adds any arguments that's necessary to make it work. So this is used by "R", and in this case it just says that is a well-typed expression and it needs one more argument. And unfortunately, "A" still doesn't solve it correctly for us. So undo, reload, and we'll just write out what we want, which is x plus y. And then we use "G" to give it to agda. Continuing, we'll make vectors so we can have a somewhat more interesting usage of some of the features later on. So we have our empty vector and cons. Again, "L" to reload, just to make sure everything is correct so far. And now we'll define the vector concat. So v concat takes a type, two naturals. You still have access to all the normal vim thing, so was an autocomplete thing that I actually don't use, but sometimes typo into. And we want to take two vectors and concatenating them should give us the sum of their lengths. And again, same pattern where we actually just define the parameters and leave the body as a goal so that we can do a case analysis. So let's do something a little bit different. So we change the code, we put in a new hole, but now we're going to specify a parameter to the auto command, and there's a parameter C that says also try to do case analysis. So this is a way for us to give input to the auto command, which does not prompt you. If you use it on an empty hole, it just immediately tries with the default, but if you fill the hole with some options, then it will use those, and in this case it completely solves the problem. And then we can see, other than some less than friendly names, this is exactly the code that we would want. So another feature that might be useful is we can normalize expressions. So just using the example from the simple introduction, we'll define low to be 1 and high to be 1 plus 1, and we can use "n", and again it asks us what do we want to normalize, and if we want to normalize the high expression, and we see that it will normalize to 2. There's also "t", which will take an expression, or if you're over a hole, use whatever expression's in the hole, and will tell us the type. So we can ask, what is the type of high? And it tells us it's a natural number. If we look back at the commands, there's a few we haven't talked about yet. In particular, there are two forms of normalize and two forms of refine, and there's a context command that's very useful as well. The two forms of normalize specify whether or not we want to unfold abstract definitions, and similarly for refine. And so the capital version, so "N", will unfold abstract definitions, and similarly for refine, "R", will refine and unfold abstract definitions. So let's actually see the environment case as that's a rather useful feature. So we'll clear out this body and use L to reload, and then E to get the environment. And you can see at the bottom, it tells us what the goal is, which is we want a vector of type A with length m, and we currently have just some expression that has v1 and v2 as parameters. If we had some body here, for example, if we had v2 here, and we did E, we'd see our goal is to have a vector of type A of length m, and we have in this hole a vector of type A of type n, so G should work and should give us our solution. So there are a few more other commands that aren't accessed typically through the normal mode that I want to briefly talk about. And you can see them here, and just simply by looking at the source to the plugin. And at the bottom is all the commands, and you can see that they're defined with the local leader. But there's also some X commands. In particular, the one you would most probably want to use are the toggle implicit arguments, which is just in any of those little info messages that pop up, whether it will show you the implicit arguments or not. And the read-write mode you may want to change if you want agda to, and we can simply look at the source code and we see there are 4 options: as is, normalized, head normal, and instantiated, and it specifies how aggressively agda normalizes in certain cases. You can see at the bottom the control commands to show you the whatever goals are available and to jump to the next and previous goals, which are also accessible through the M to get the metas, so that's just another way of saying the unsolved goals, or through the command, the metas command. And there are a few other commands that you can play with to see what they do, but for the most part, you won't usually use them. So the last thing I would like to show is the agda-vim mode doesn't automatically reload before doing everything to make sure your file's up to date, and the reason is it can sometimes take a bit of time. So this is a larger example of code, and it imports more modules, and when you load it, agda will verify and check that all the modules you imported haven't been updated, and so that it doesn't have to recompile them, and if they have, it will recompile them. So I'm just going to reload this, and you can see it takes about a second or two to go through all that. So when you do just a normal case analysis or use the G to give an expression, it does not need to do all of that. But it's fairly often that you do need to reload the file manually. Typically when you add new code, agda won't be aware of it until you reload the file. It generally doesn't take too long, but it's usually on the order of a few seconds for more complicated files. So, one last thing I would like to mention, but I won't demonstrate, or actually a few last things. One is when the auto command is executed, it has a default timeout of 5 seconds, and Vim simply waits until it gets a response. So if the auto feature fails because it can't find a solution in the time limit, Vim will simply be unresponsive for that time, which can sometimes be annoying. Another aspect is the features are integrated with the make command, so let's actually make an error and use make to rebuild, and this will call agda, and you can see at the bottom that it tells us what the type error is, and we'll also see that it uses the quick fix window of Vim and highlights the error, has the error message in the quick fix windows and jumps to it, and if there's multiple errors, and goals as well will also show up here, and we can actually see that. If I replace this with the goal and reload, we see the error goes away, but now we have in the quick fix window a goal, and if we hit enter on top of it, we'll go straight to the goal. And if we had multiple goals, there would be multiple entries. Here's where that Control WO is useful to close everything else. So this completes the introduction. Feel free to find the source code on GitHub and make any changes that you might need.